This is May Murphy.
And this is Cameron Wahlberg, and our project is Reconstruction.
The City of Des Moines declared 54 sites in the local area a public nuisance, which are projected to be demolished in the next 5 years, with more in the future. Rather than promoting the nuisance ideals, which feeds into the history of redlining and gentrification in Des Moines, we propose techniques to provide care on a material scale for these structures. The demolition techniques currently in place in the Midwest are harsh, toxic, destructive, and lead to a large amount of waste ending up in landfills. Using resources provided by the proposed building, we will give agency to robotic deconstruction, maintenance, and reconstruction in a precise and consistent method only obtained in robotic processes.
The East Des Moines Depot at 120 East 5th Street in Des Moines, Iowa, was built in 1909 and served as a train depot along the rail line through the 20s. It outgrew its original program and was developed into a tomato storage unit. Its eventual abandonment signaled the end of its programmatic use, and the building consists of valuable elements such as terracotta brick, hardwood floors, and slate shingle roofing. But what can we do with its existing material narrative?
The depot is an ideal location to implement a delicate choreography between innovative robotic technology and materials on site. Technology such as KUKA arms, material lift enhancers, concrete recycling robots, site analysis drones, bricklaying robots, and Brock machines will carefully dissect the depot in order to preserve the materials.
Located 20 feet from an inactive rail line system, the rail will be reinvested back into the larger transportation system of Des Moines and the Midwest to transport machines, material, and resources. This reintroduced knowledge network creates a map of connectivity. This laboratory houses safe testing, researching, and maintaining that can occur through the lens of material substance. This new typology will house a system of robots and resources focused on surgically extracting materials from existing infrastructure in the United States Midwest in places like Des Moines, Iowa.
A mutual relationship between human and robot will prepare buildings on site for demolition and maintenance by carefully extracting, salvaging, and caring for material. It will then be collected, tagged, analyzed, researched, and cataloged. The public is invited to experience these stories through physical embodiments and sculptural artifacts on site. The excess components will either be stored or reconstructed into building ingredients using robotic construction, artificial intelligence, and machine learning methods.
Analyzing the building completely, it consists of reused concrete from existing sites, repurposed terracotta brick, metal and wood studs, and cast-in-place recycled concrete. The building is set up for passive solar heat gain and solar energy production, as well as operable ventilation systems. Its adjacency toward the now active rail line allows for direct access to the labs and warehouses for material to come in from sites.
The layout of the building allows for a distinction between public versus private, keeping public spaces to the periphery of the building and private in the interior. The surrounding site will be used for material storage and a public access space of an annual pavilion located on the now ghosted foundations of the depot.
The interior of the space is divided with visual collisions in mind. There are opportunities for visual connection through the workshop and labs, demystifying these deconstruction and reconstruction practices. Using construction design software like Grasshopper, the robots have the capability to produce a variety of facade iterations, with brick being one example.
Material analysis, maintenance, and reconstruction challenges the way preservation is defined through robotic synthesis in the building and allows for an alternative form of historic preservation. In contrast to traditional preservation techniques to perfectly restore structures, this process recognizes the importance of the material narrative in terms of its history, journey, and larger role of the building components.
The earth and materials extracted from it have a story to tell embedded in the built environment. The questions arise. Are these materials deemed important enough to preserve, and in what capacity? How do we preserve these artifacts in a sustainable structure and give the materials the space they deserve?